Ham Radio in Space, from Oscar 1 to the ARIS program, presented by Steve White, W4SNW, with the Sarasota Emergency Radio Club, Inc. First, let's talk about Project Oscar, orbiting satellites carrying amateur radio. A couple trivia questions. When was the first Oscar launched? What message was sent by Oscar 1? How many Oscars have been launched? And how many countries have built Oscars? And for the answers, December 12th, 1961, only 4 years after the Russians launched Sputnik 1. We were in space that early. And the only message sent was hi hi in CW. Dit 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 dit. 121 Oscars have been launched over the years, and 30 different countries have participated. It's really an amateur radio global phenomenon. Again, Oscar 1 was launched from Vandenberg Air Force Base in California, and interestingly, it was aboard a highly classified U.S. Air Force Corona spy satellite mission. The mission of the main satellite was to film Soviet missile launch and other military installations. And curiously, it was film. And they would release these canisters to come back in through the atmosphere. It would come in, it would be on a parachute system, and a C-119, something called a flying boxcar, would snatch it in midair, and they would develop the film, and that's how they did their classified work. Subsequently, there was also Poppy, another classified Soviet mission. Why was a ham radio satellite on this? For a couple reasons. A group of amateur radio operators and engineers from Lockheed were doing this kind of as a side project while they were working on actual government satellites. And this was a very dedicated team. It says here they only did it for $63, with many borrowed components, I'm sure, from other programs. But they really were the Project Oscar program, and they did the first 3 or 4 of these. It only was up for about 20 days. 28 different countries copied the hi hi CW message. Now, Lance Ginner, K6GSJ, did a great presentation, and there's a link to his YouTube presentation on Project Oscar. He's a young engineer. The team is well identified. You can see Oscar 1 was less than a square foot, basically, and they had to use the technology of the day, which was very limited. They literally were only on 2 meters. They didn't use split band at that time. So you can imagine trying to get a receiver and a transmitter to work and not essentially interfere with each other. And they used a lot of interesting engineering techniques. I highly recommend you watch this YouTube link and see some of the challenges that they had. Eventually they got early solar panels for power. They standardized the size. That's where you got the CubeSat type technology. Now, by the 5th mission, AMSAT came on board, the Radio Amateur Satellite Corporation, still very active today, in 1969. And that was an Australian Oscar 5, which was the first project they collaborated on. And they've spearheaded, like I said, CubeSats, small sats. They've had 25 satellite projects, 19 successfully launched, and they continue to be extremely active in encouraging other organizations to learn about the technology, design, and build their own satellites. Now, some of the early satellites were ballast to kind of provide just weight to test some of the launch vehicles, the rockets, but today they sort of have to pay retail, maybe at a discount, to get space on these other rockets to launch our Oscars. If you're interested in AMSAT, we have a great opportunity coming up in October 2024 in Tampa. So go to their website. You can find out more about it. Essentially, it's an organizational meeting. I'm sure they'll have some technical discussions and, again, right up the road. Now, the actual Oscars are essentially repeaters. They have transponder modes, digital computers. They have message, store and forward messaging capabilities. Today, most use a split band. Again, avoid some of the intermod issues. Can't put big, cavity filters up on these things. It's just too small. And they have modes up to 2.3 gigahertz. As an aside, anything going into space has to go through shake tables, vibration tests. I once was working with a group out of Drexel designing what was called a gas can, a little science experiment that would have been in the Shuttle Bay canister, and you had to make sure it didn't have outgassing. There were many technical requirements before you could put anything up into the space on board, essentially a space shuttle or rocket. Now, in addition to just the straight communication, they also did a number of science experiments, ionospheric research, sea meteor sounding, radio astronomy, and quite a few others, as well as some cameras. So, as the technology improves, becomes more miniaturized, there were no ICs back in the early Oscar program. They were able to, put a lot more capability up on these satellites. Now, here is the full list. I'm not going to go through them because there's so many pages. I'll scroll briefly. You can see some of the other participants. But I did want to mention Oscar 3. Interesting story. The third stage booster failed. Now, this is a military satellite mission. There are multiple payloads, including Oscar 3. And because the orbit was not as expected, nobody could figure out where these satellites were except for the ham radio operators. They could track Oscar 3. They literally would take a string on a big oversized National Geographic globe. They would run it from acquisition of signal to loss of signal, and they would track it over a number of days. And using the ham radio, and the engineers at Lockheed participated, the hams there, all the satellites could then be figured out where they were in space, and that was very interesting. Now, we also have satellites that are low Earth orbit. We have geosynchronous, and a number are kind of elliptical. So again, I'll just scroll through. You can see some, there's Surrey in England, Melbourne in Australia, a lot of Japan, and some countries you wouldn't normally think of are actually represented here. The French, Korea, you'll see Hungary is in here, Italy, Haifa, it'll be Israel, Mexico, it goes on and on. Indonesia's participated in it. Naval Academy's been very, very active with it. Jordan, United Arab Emirates, Saudi Arabia, so they're all participating. We're an equal opportunity platform, I guess, for amateur radio operators around the world, as we are for international goodwill in the hobby in general. Russia's also participated. So again, if you're interested in learning more, you can go to, you can just basically Google the Oscar program and you can get links and get more details on all these various launches. And it's too long to go through the whole list, but they are here for reference, and I think you might find some of this very interesting. The last one in the series, Oscar 121, a Spanish project, was launched last November 2023. Again, AMSAT with European partners has been very active with that. So the question is, okay, that's cool. How do you talk to them? You have a couple websites, or quite a few, but here's two. The N2YO.com has a satellite tracking website, and you can use that to figure out where many of these satellites are. Also good for EME, Earth, or Moon bounce contacts. And DXZone also has a link for satellite tracking software, which is also a great way to do it yourself. Now, just a brief mention, look at the antennas. They are cross-polarized. And the reason for that is Doppler shift. As you probably know, the apparent change in frequency as an object approaches goes higher, and as it passes, it goes lower. And you can get phase variations, which could be a loss of signal. This is a classic train whistle, situation we've heard. So we use these cross-polarized antennas generally, and you can see they're not very elaborate or heavy duty. Now, a lot of people will have azimuth, elevation antennas, higher gain. They're motorized for tracking. Again, they use that a lot for moon bounce. But this is essentially all you need to work through the satellites. Shifting gears, SAREX, Shuttle Amateur Radio Experiment. Near and dear to my heart for a couple reasons. Let's start with Owen Garriott. W5LFL, the first amateur operator have any communication with the general public other than on government frequencies and purposes. He was on Space Shuttle Columbia in 1983. He was also designated Space Lab 1. He was a mission specialist, just using an HT and a little square low type antenna in the shuttle window. I heard him, didn't have the ability to contact him, but I did hear him on one of the passes, which made me very interested in trying to get more involved. I will say my interest in space and satellites goes way back to being a Boy Scout and seeing the Telstar satellite go overhead at a Boy Scout campfire at camp, and I was just fascinated that you could actually see something in space. So that was pretty cool. This mission, Tony England, W0ORE, was in August of 1985. He was on Challenger, the mission before the tragic explosion the following January. It was also designated Skylab 2. STS-51F was the mission designation. And on this mission, he only made 130 contacts and sent and received 20 images via slow scan TV, which is the first time slow scan was ever used in the space shuttle. Why is this so significant? Well, one of those 20 contacts was with W3YC. This was the Project Spark Aerospace Magnet School program from Northeast High School, and we operated from the Franklin Institute in Philadelphia. I built the antenna that was used for that contact. It was a cross dipole. It kind of had a chicken wire reflector on a wooden base. My teenage amateur radio club, Germantown Radio Club, later Suburban, many of our young teenage members became broadcast engineers. We had a lot of support from the local TV stations. They covered the event. And we were using a multi-mode 2-meter transceiver with a 300-watt Dentron linear. And we were able to make that contact. And today, many of the astronauts and cosmonauts have their ham radio licenses. They make contacts regularly. We'll talk about the International Space Station in a moment. And they even used ham radio for a QSO with cosmonauts aboard the Russian Mir. And there was once a communications problem on one of the missions. And Mission Control, they used the ham radio for an emergency backup communications link, which was very cool. You can see quite a few of the space shuttle missions did have an amateur radio component. They could use it for just a little downtime entertainment, a little diversion from their regular mission duties, or they could have scheduled QSOs. And this was really the basis for now a lot of the scheduled Ares contacts, which we'll talk about next. So, the amateur radio on the International Space Station program, very, very active. It allows kids in schools and different groups to talk to astronauts in space. Sometimes they can use slow scan as well. And they ask a few questions. The acquisition of signal to loss of signal, about 10 minutes plus or minus. The shuttle is not really in a very high orbit, 200 miles plus or minus. But it's a great opportunity for STEM and ham radio exposure. Now, this is the bottom line of the whole presentation. Experienced ham radio operators with the proper equipment and capability can apply for a scheduled contact with the International Space Station. Now, as you can see, the deadline has passed for next year's, but I'd love us to try to work with a group with experience, credibility, with the Ares group, to try to arrange a 2026 contact with Girl Scout Troop 860. Many of you were here when the troop earned their badge. It's a special ARRL Girl Scout badge involving ham radio. They went through a lot of different stations, learned a lot of different things, got on the air. And my granddaughter and niece are both in Girl Scout Troop 860. So that would be a lovely project for the club for the next year to try to put together a program to apply for an Ares contact. And with that, thank you very much.